refresh my memory as to the steps involved with solving by substitution. Class.
Well, your first step is you need to solve or set a single variable. Does it matter which equation you choose? No. Well, okay, so I did for the blue one, the 2x, I said y equals 2. I solved for y.
Okay, so what you're saying is the strategy that you used is you solved one of your equations for one of your variables. Okay? And you chose the easy one because work smarter, not harder. Right? Okay? Alright? So you went blue for y. I agree. I would concur. Blue for y is the best thing to go. So we solved one of our equations for one of our variables. So I'm going to here add 2x to both sides. And so that's then going to be y equals 2x plus 4. What if I said y equals 4 plus 2x? Doesn't matter. Same thing. Right? Okay? Alright? Somebody other than Lexi. Now what? Okay. So I'm going to take this 2x plus 4 and I'm going to put it in place of y in my other equation. Okay? So written out, that would be, we're going to substitute, hence the name substitution. I'm going to substitute what we just solved in number 1 into the second equation to replace that variable that we just solved for. Oops, wrong way. That way. Okay? So that's then going to be 3x plus 2 times 2x plus 4, and that's got to equal 1. Agree? Now what? Now I'm going to solve that for x. I'm going to solve my new equation. So that's 3x plus 4x plus 8 equals 1. 3x plus 4x is 7x. Subtract 8 from both sides gets me 7x equals negative 7. Divide both sides by 7 gives me x equals negative 1. Yes? Okay. Now what? Okay. Could I also go there? Does it matter which one I go into? Doesn't matter, I can go into either one. Okay. So negative 2 times negative 1 plus y equals 4. So that's positive 2 plus y equals 4. So y equals 2. Okay? So we substitute it in to find the second variable. Now what? Where do I put them in? Well, where? Not in either one. In both. Which kind of equations? Because we got a bunch of equations on there, right? Both of the original ones. Yep, I plug them both back into the originals to check, just to make sure that I did my work right. Okay? So I'm plugging them both in the equations to check that if you are correct or not. Okay? So If I plug in -1 in for x, I get -3. If I plug 2 in for y, I get 4. -3 plus 4 is +1. +1 is equal to +1 and checks out in the red. -1 times -2 is +2. 2 plus 2 is 4. 4 is equal to 4. I did it right. Okay? Now, that check, I was verbalizing that check, so it took me a little longer. Okay? 15 seconds, maybe? Maybe 10? And I know now for a fact that I got this one right. Okay? You decide on the importance of that check. Me, I think it's pretty important. Because I know for a fact I'm right. I got 100%. And come Thursday when we have a test, or a quiz I should say, we have a quiz, I'll know my score leaving that quiz. Okay? Or Monday when I turn in my take-home test over the weekend, I know what my score is. Okay? Alright? Now, the only difference is how we write that answer. And we write that answer in point form, or ordered pair form. Okay? We don't just leave it x equals and y equals. We write it as a point because it's that point where those two lines intersect. Okay? Give you a quick second to do those, because we haven't gotten those, if you weren't writing those down. Move this over a little bit so I can actually see it. So I would probably solve this right one for x by subtracting 5y from both sides. Then I would plug that into the left one. So that's going to be 4 times -9 minus 5y. Then plus 3y, and that's going to be -2. So that's -36 minus 20y plus 3y equals -2. So that's -17y equals +34. So y is equal to -2. If y is equal to -2, then x plus 5 times -2 has to equal -9. So that's x minus 10 equals -9. So that gives me x equals +1. 4 minus 6 is -2. 1 minus 10 is -9. Checks out in both equations. 1, -2 is my solution. Yes? Yeah? Try that one. So if you don't like fractions, you gotta get rid of them. So I'd multiply this whole thing here by, actually let's do it in green. I'd have to multiply this whole thing here by 3. So that's going to give me then 2x plus 9y equals -102. This one, I would multiply by 4. That's going to give me 2x minus y equals -2. Okay? Yes? Now, let me show you a little different kind of substitution to go along with this. Okay? If I solve this bottom equation for 2x, I would get 2x equals y minus 2. Do we agree with that? Now, could I take this and plug it in for 2x? Yeah, I can. Okay. So then this would become y minus 2 plus 9y equals negative 102. It doesn't always have to be a variable. You can solve it for what's in the other one. Okay? We could have solved it if we want. It would have been tough, but we could have solved it for like 102 or something like that. You know what I mean? Okay? So then that's going to be 10y equals negative 100. So y equals negative 10. X minus negative 10 equals negative 2. 2x plus 10 equals negative 2. 2x equals negative 12. X equals negative 6. Negative 6 times 2/3 is negative 4. 3 times negative 10 is negative 30. Negative 30 plus negative 4 is negative 34. Checks out my first equation. Negative 6 times 1/2 is negative 3. Negative 10 times 1/4 is negative 2.5. Negative 3 minus negative 2.5 is negative 1/2. Checks out in both. So my answer here is negative 6, comma, negative 10. Always check your answers. Okay. Two special situations then to go along with it. Okay. So if I solve my first equation for 3x, or if I solve it for x, I should say, so then that was going to be 3x equals 6y plus 14. Divide both sides by 3. X equals 2y plus 14/3. Plug that into my other equation. Negative 6 times 2y plus 14/3 plus 12y equals negative 16. That gives me negative 12y minus 28 plus 12y equals negative 16, which then gives me that. What's wrong with that? It's an untrue statement. Okay, that's one thing that's wrong. But more importantly, there's no variables in that statement. Okay? So that gives me a false statement without variables. So my answer here is no solution. Situation number 2. If I take my top equation and I solve it for 2x, then I can plug that into my, then I can plug that into my bottom equation. That would give me negative 4y minus 13 plus 4y equals negative 13. That gives me negative 13 equals negative 13. What's wrong with that statement? Just doesn't have any variables, right? Okay. So that is a true statement. Without variables. That gives me infinite solutions. Which is my 3 scenarios. Remembering back to last week, Wednesday, when we were talking about solving things by graphing, we had 3 different possible solutions. If my variables cancel out and it results in a true sentence, that's infinite solutions. Okay? Because the lines are the same. Okay? So everything's going to cancel out. We're going to get a true sentence. Infinite solutions. Variables canceling out results in a false sentence, or that's going to give me no solution. Yep. That's those parallel line ones. Variables don't cancel. That's going to end up being a point. Yep. Yeah, buddy? Good news, bad news. Bad news first? Do tomorrow. Good news. 6 problems. 7, 9, 11, 13, 47, 55. 6 problems. Okay. Good news, bad news. Bad news? Forget what the bad news was for the second one. Forget what the bad news was.
Quiz on Thursday.
Well, there's quiz on Thursday, and a take-home quiz on Thursday too.
Good news, there's no formula requirement, right?
Good news, no graphing on this one.
Oh, cool.
Bad news, no graph over.
Okay.